Statistics is the art of learning from data. Now, majorly speaking, it is divided mainly into three broad categories: descriptive statistics, inferential statistics, and predictive statistics. Descriptive statistics is mainly concerned with summarizing the data that we have. For example, say if you have the marks data for two classes in mathematics course. Now the question is, which of the two classes performed better? You start by calculating the average score for both of the classes, and you conclude by saying that class A performed better than class B. This average is also called as mean. Now, if you had data like this, although they have same mean value, but the distribution tells a very different story. Here we use what is called as median to conclude that class B performed better than class A. Median is the point that divides the data above and below 50%. Now this mean and median are also called the measure of central tendency. They measure how well most of the students perform. Now take a look at this data. Same mean and same median. Now instead of directly answering the question which of the classes perform better, we focus on the insights that this distribution provides. In class B, we see some students with very high score, some students with average score, and also some student with very less score. Now in class A, we don't see many high scores or very poor performance, but most of them are average performers. So this statistics in which we use descriptive measures and distributions to summarize the data is called as descriptive statistics. Now inferential statistics focuses on making conclusion about a whole population from a small sample of data. Imagine your school has 1,000 students and you randomly select 100 students and ask if math was their favorite subject or not. Now you find that 55 students out of those 100 students said they like math. Then you can use inferential statistics to infer that probably 55% of all the 1,000 students like math. Now, you didn't ask all the 1,000 students if math was their favorite subject or not. You used a sample to make smart guess about the whole population. Now, predictive statistics. Here you use the data that you have to make predictions about future. It includes things like regression analysis, time series, classification, clustering, probability, and many more. In machine learning, linear regression uses correlation and variance. Logistic regression uses Bernoulli likelihood. Naive Bayes uses probability and Bayes theorem. K-nearest neighbor uses kernel density estimation and distance matrices. PCA uses covariance matrices. Random forest uses bootstrapping and aggregation. So you see that almost every machine learning algorithm has root in statistical concept. Now don't worry if you don't know all of these concepts, I will discuss them in other video. This was just to show you what statistics is all about and why is it so important for data science and machine learning. So in statistics, we can describe the data that we have, make inferences or conclusions about a larger data, and also make predictions on future unseen data.